This is number 35 from section 3.3. It's a two-parter. In part A, we're asked to find the equation of the tangent line to the graph of the function y equals the tangent of x at the point pi over 4 comma 1. So we have the whole entire point, both the x and the y, and we have the function. So the only thing left we need is the slope of the line, and we're going to get that from the derivative of the function. So dy dx in this case will be the derivative of the tangent function, which is the secant squared of x. So now we want to evaluate that derivative, dy dx, at the point where x is equal to pi over 4. So this is going to look like secant squared of pi over 4. So the secant function, we recall, is the reciprocal of the cosine function. So we can think of it this way, 1 over the cosine of x. So I recall that the cosine function has a value of the square root of 2 over 2 at pi over 4. So if the cosine of pi over 4 is root 2 over 2, then the secant of pi over 4 is 2 over root 2. It's the reciprocal. So I can now move on and say this would be 2 over the square root of 2 quantity squared. Well, that becomes then 4 on top, 2 on bottom. So the slope of this tangent line must be 2. So for my equation, I'm looking at y equals the slope, pi over 4, excuse me, that's not the slope. The slope is 2 times x minus the x value of the point, pi over 4, plus the y value of the point, 1. Part B of this question asks for the equation of the tangent line to the inverse of the function in part A. This is the arctangent or inverse tangent function. And we're asked to find the equation of the tangent line at the point 1 comma pi over 4. So that is a reversing of the A and B values from part A. If you think of it this way, pi over 4 could be A, while 1 could be B, and then this is B and A. The equation or the function in part A could be f of x, and then this is the function f inverse of x. So if we recall from this lesson, there is a reciprocal relationship between slopes of tangent lines or values of derivatives of inverse functions at AB and then BA. So the reciprocal relationship is going to tell us, since the slope in part A was 2, the slope in part B is going to be 1 over 2. So that comes from the fact we're just taking the reciprocal of 2, and we can do that because the function in part B is the inverse of the function in part A, and the point at which we want that derivative value is a flip-flop or a changing of the domain and range of the point from part A. So that makes this equation pretty easy to write. It's going to be y equals the slope, which is 1/2, times x minus the x value of the point, plus the y value of the point, pi over 4. And that's number 35 from section 3.3.